So in 7.2 we have similar polygons, and similar polygons have the same shape but not necessarily the same size. You can see in the picture, same shape, not the same size. And two polygons are similar if and only if their corresponding angles are congruent and corresponding side lengths are proportional. So in this diagram, you can see that ABCD is similar to WXYZ. All the corresponding angles are congruent, and the corresponding sides are proportional. Right? So if we're given two polygons are similar, then we can create the proportion. Well, we can say the corresponding angles are congruent. So we could say that A is congruent with W. So we could say angle A congruent angle W. We can also say angle B congruent to angle X. And if we don't have the diagram, it goes in order, right? So A is congruent with W, B is congruent with X, and C is congruent with Y, and D is congruent with Z. Right? Right, so we have angle C congruent to angle Y, and angle D is congruent to angle Z, like so. And then the corresponding sides are congruent. And again, if we don't have the figure, we can just go by the name of the polygon. So here side AB is congruent with side WX. So AB, or maybe I can go ahead, instead of writing the congruency signs, I can write the proportions, right? So let's go ahead and write the proportions. So we got measure of AB over the measure of WX is equal to the measure of BC over XY, and that's equal to the measure of CD over YZ, and that's equal to DA over ZY. I'm sorry, ZW. So we could say all the angles are congruent, and if we're given that they are similar, then all the corresponding sides are congruent. So these two are congruent, those two are congruent. Oh, I'm sorry. We could write the ratio that this side over this side is equal to this side over this side, and that's equal to this side over this side, and that's equal to this side over that side, which is what we have here. Okay, and we can use this property of similar polygons to solve problems. So let's go ahead and look at the first problem here. Kuma wants to use the rectangular photo shown here as a background for her computer, but she needs to resize it, determine whether the following rectangle images are similar, and if so, we write the similarity statement and scale factor. Right? So what's the similarity statement? It is going to be this statement here, right? So first polygon tilde second polygon. And so how can we tell if these two rectangles are similar? Well, what's the definition? It's that the angles are congruent and the corresponding side lengths are proportional. So they're rectangles, so all the angles are right angles. They're all congruent. So we only need to worry about the side lengths, right? So we'll put BC over FG is equal to DC over HG. So if these two polygons are similar, then this equation will hold, right? The proportion will hold. So let's go ahead and substitute in the values and see if it's true. So we have BC is 8 over FG is 10, and then we got DC. Ooh, what did I say? DC? No, I'm sorry. This should have been. Oh, I'm doing this wrong. 8 over 12, my bad, is equal to DC is 10 over HG is 14. Alright. So if these two triangles are similar, then this equation will hold, right? So let's go ahead and check this. This is going to be 8 times 4 is 122, I believe. Let me double check. 8 times 14, 112. And then the other side is going to be 120. So these two triangles here are not similar. Right, not similar, because 112 is not equal to 120. So now let's go ahead and check these two. Now let's go ahead and check these two and see if they are the same. So we'll do 8. This is part A, and this is part B. So it'd be 8 over 12 is equal to 10 over 15. Yeah, that's right. So then it's going to be 120 is equal to 80 times 15, which is also 120. So then we could say that these two polygons are similar. Okay, and so let's write our similarity statement. It's going to be polygon A, B, C, D similar to polygon J, K, L, M, like so. And the order here matters, right? So A, we start with A and J, then we go to B and K, then C and D, C and L, and then M and D, right? So the order here matters. All right, let's go ahead and down here, we have the fact that these two polygons are similar, right? And again, the order matters. So A matches up with V. So I'm going to draw a little line like that. A matches up with V. And then we go to C and W. So we're going clockwise, right, on both of these polygons. Okay, so we're now trying to find X and Y, right? Find the missing measures. So we can do that because we can create ratios with the sides, right? Let's first start with this side. Let's see. So this side matches up with this side here. So we got 9 over 6, right? Because these two sides match up. 9 over 6 is equal to, these two sides match up as well. So it'd be 12 over 3y minus 1. So let's go ahead and work that out, and we get 9 times 3y minus 1 is equal to 72. 27y minus 9 is equal to 72. 27y is equal to, and we're going to add 9 to both sides, and we get 81. Did I do the math right? Give me a second. Let me double check. So we got 9 over 6 is equal to 12 over, yep, that's right. And then we get 27y minus 9 is equal to 72. That's right. Okay, so we're good. So then y is going to equal to 40 and 1/2. Okay. And so now we want to find x, and so we can do the same thing just differently. So we can do 9 over 6 is equal to, because those two sides match up, and then these two sides match up, right? So we can do x over 10. And then we solve this proportion, and we'll get 6x is equal to 90. So then that means that x is equal to 1/5. Right, so then you are supposed to do the other exercises here, including this one up here. Don't forget this one here.